In this video, we're learning about metric relations in right triangles. Metric relations is basically a result of a special situation involving similar triangles when you have a right triangle that's drawn with the height. So when we have our right triangle with the height, we create three sets of similar triangles. So we can see here we have one triangle, which is the big one that's drawn here. Then we have the smaller one on the right. And then we also have this one. So these three triangles are similar, and I'm going to illustrate with an example. So to illustrate, I'm going to put in angles in my triangles. Well, the first one we can put in is this angle. Here we know it's 90 degrees because it's the height. The height is always parallel to the base. Well, and if this one's 90, then this one's going to be 90 also. Okay, so I'm just going to put in some numbers just hypothetically. Let's guess, or let's say that this angle is 60 degrees. Well, if this angle was 60 degrees here, and we know this angle is 90, well, the angles inside this triangle add up to 180. So that means this angle is going to have to be 180 minus 60 minus 90. And that gives us 30 degrees. And if we look at the big triangle here, well, we know that this angle in here is 90, and we know this angle is 60, so that means that this angle is also 30. And then the last angle that's left is this one in here. Well, we know that this one's 90, this one's 30, so that means that this one that's left in here is going to be 60 degrees. So there we have our three sets of similar triangles, and they're similar by angle, because our blue triangle here has an angle of 60, 90, and 30. Our pink triangle also has 60, 90, and 30. And then the big green triangle also has 60. This angle in here is 90 and 30. So they all have the same angles in the triangle, so that means all three triangles are similar. And since we have three sets of similar triangles, there's many special properties that can be applied, and this is where our formulas are going to be coming from. Before we get into our formulas, we're going to talk about how to properly label the triangle. So if you think back to when we were doing Pythagorean theorem, we always labeled the sides of a right triangle as A, B, and C. So the hypotenuse, which is across from the 90-degree angle, so I'm just looking at the big triangle. The hypotenuse we always labeled C, so I'm going to call this C. So that's for this side. That's my C. And then the other two sides are going to be A and B. Okay, now here, this here, well, that we usually call it the height, so we'll label it H. And then the other two sides that are left are these small ones, so we call this one M and this one N. It's very important that you label the sides properly to apply the formulas correctly. So I just want to point out to you, the C is always the hypotenuse across from the 90-degree angle. After that, it's easier to label these sides alphabetically. A comes before B, so we write A, and we read left to right, A then B, and M comes before N. Alphabetically again, M and then N. Once we've properly labeled the triangle, then we can apply our formulas. So now let's look at the formulas. Here I have my diagram. My triangles labeled the exact same way as I just did in the other example. The first formula is this one, A squared equals M times C. So that's this side, A squared equals M times C. The other one that kind of goes with it, it's the opposite, it's going to be using B and N this time. So it's this formula. B squared equals N times C. So the idea is that it's the leg, and this here we call it the projection. It's if we rotated this down here, this would be on top of this. So it's the leg squared equals the projection times the hypotenuse. So A squared equals M times C, B squared equals N times C. Now if we look at the next one, this next one deals with the height. So the height is equal to M times N. So the height squared, not just the height squared is equal to M times N. And then the last one is this one down here. I'm just going to move this up. And now we see the formula. So here, this one deals with the A and B. So A times B equals C times height. I'm not going to get into where these formulas come from in this video. We'll discuss it further in class, but it has to do with proportions of sides, and it has to do with the fact that sides in a similar triangles are proportional. And this one here deals with area, how the area is proportional or the same in our triangle. So I will discuss that further in class. Now we'll use those formulas to solve problems. So these are the steps to follow when you're solving a question that deals with metric relations. So the first step is to identify that it's a metric relations question. So if we look at this example here, example A, well, we can see right away it's a right triangle and it has the height drawn in it. So it's for sure a metric relations question. Step 2 is to label the diagram using the appropriate letters. So we're going to label our sides A, B, C, H, M, and N. So I'm going to do that right away on the triangle I have here. So this is my A, B, C. C is the hypotenuse, is across from the 90-degree angle. This is the height, and then alphabetically this is going to be M, and this is N. Okay, now that we've labeled the sides, we're on to step 3. We have to decide what formula we're going to be using for this. So I've written the formulas here for you, so you can compare. My formulas are here. I need to decide which one I'm going to be using. Well, I need to look at what I have to find and what I'm given. So if I look here, I can see that I know what the M is, and I know what the N is. So I need a formula that has M and that has N. So for example, this one has M and N in it, and it's to use to find the height. Is the height what we're looking for here? Well, if I look at my example, I can see that, yeah, I need to find the height, and I know the M and the N. So I'm going to use this formula. So I'm going to write the formula. It's very important you always start by writing the formula. So the formula is h squared equals m times n. So h squared is equal, I put in the value of m, which is 4, times the value of n, which is 9. Do the multiplication. So I have h squared equals 36. And then I need to square root both sides to get h by itself. So I'm getting h is equal to 6. Okay, now that I know 6, I'm going to write it into my diagram for h. And now I can use this to solve for other missing values. I can use the new value I just found. So now I need to find a. So I need to look at my formulas that contain a. Well, this one here contains a, and this one contains a. In order to use it, I need to make sure I have all the other values. So if I look at this one, I need to know B, C, and H to be able to use it. Well, I know C because C is 4 plus 9. It's going to give us 13. And I know H, I've already found it, but I don't know B yet. So I may not want to use that formula. The other formula, this one here, uses M and C. Well, I know M and I know C, so I'm going to use that formula. So I'm going to start by writing it down. A squared equals M times C. So A squared equals 4 times 13. A squared equals 52. 4 times 13 is 52. And then I square root both sides. So I'm going to write it up here. I get A is equal to 7.21. Okay, and then I've solved now for both of these question marks. I'm done example A. Now let's take a look at example B. So my first step, I have to identify if this is a metric relation, and it is. It's a 90-degree triangle, a right triangle, and the height's drawn in. So the next step is to label the sides. So C is always across from the hypotenuse. Here we have A, B, my height. This is M, and this is N. Okay, I have to solve for those two question marks. Well, I have A and I have M. Those are given. I don't know the rest. So what can I do here to solve this problem? Well, let's look at the formulas that contain A and M. Maybe start with that. Well, this formula has A and M, and that's the only one. So will that be helpful? Well, it could be helpful because with this formula, I could find C. And if I know C, and I know m, which is 3, I can find n. And that could be useful after to help me find my height and to find my b. So let's start with that. So I'm going to start with a squared equals m times c. I know a is 6, so I'm going to put that in. 6 squared equals, I know m is 3, times c. I'm going to solve for c. So 6 squared is 36 equals 3 times c is 3c, and then I'm going to divide both sides by 3. So I get c equals 12. Okay, well if I know c is 12, I can find n, because n is going to be 12 minus 3. So my n is 9. So I found c is 12. I found n is 9. Now I need to find the height. So to find the height, if I look at the formulas that contain the height, well, this one does. All I need is m and n, and I have both of those. So I'm going to use that to find the height. So height squared equals m times n. I'd like you to pause the video here and try to solve this, please. Okay, so I'm going to quickly go through the solution. M times n, so 3 times 9, get h squared equals 27, square root both sides. So you should have gotten that the height is equal to 5.2. Okay, so I found one of my question marks. Now I still need to find b here. Well, there's a couple ways you could be doing this. If we look at our formulas, we can see that I could use this one, n times c. I know n and I know c. But you could also use the Pythagorean theorem, and that's always okay. You can always use the Pythagorean theorem in these problems if you have the correct information. We know a and we know c. So you can use the Pythagorean theorem to find b. I'd like you to pause the video here, and I'd like you to try to find b either using this formula or using your Pythagorean theorem. Okay, so here are the solutions for finding b. I've provided both. This is if you use the formula b squared equals n times c, or if you use the Pythagorean theorem. You'll see that both give you the same answer. Oh, whoops, I noticed I made a mistake here. This should just say b. Okay, so please check your work. If you didn't get these numbers, try to find your mistake. Now I'd like you to try this problem on your own. There is only one variable you need to solve for. You need to find this. So label the triangle, try to find the length of BD, and we'll check the answers in class next time.